Hello students and welcome back to Mechanical Engineering Practice and Graphics. This week we will be covering the chapter number 12 of the book, Assembly Modeling number 1. This week we will be learning how to do assemblies in SolidWorks. But first let's review the schedule. This week you already did the second midterm on Monday and submitted yesterday. It was an easy exam. I hope you all did very well on that one. Uh, for this week, there will be no homework. You will only have to submit the third part of your project. However, even when there is no homework for this week, I suggest you to review this tutorial because I will be introducing the assembly module in SolidWorks, and that's how you're gonna put all the different parts for your final project together. Again, remember that each member has to submit 5 different parts and that each part must have at least 3 different features, as I am highlighting in this slide. Remember again that the third part of your project must be submitted to Blackboard earlier than this Sunday midnight, and that you will have to submit both the SolidWorks part file and the PDF. Since you are gonna be doing assemblies and putting all of these different parts together, I expect that you will have to do some modifications on those parts. Don't worry. If you have already submitted your part and you need to do a modification, you are free, you are allowed to do it if it's necessary. Uh, as I'm gonna show today, I will have to do a modification on one part in order to fit all the assembly together. I already shared a compressed folder in Blackboard. If you go to Blackboard, Content, and then My Folder, you will find a folder that has this compressed file. It's a zip file, and you will have to download that and unzip it. If you don't know how to do it, here are 3 different sources that will teach you how to unzip this folder, either if you're using Windows, Mac, or Linux. And if you finally are not able to uncompress the folder, here is another link in which uh, Yasamin, the other TA in the course, she shows how to do all the different parts that we will need today. So I'm gonna go to Blackboard. This is the student preview, so this is how you will see the Blackboard. First the announcement, then I'm gonna go to content, and in my folder L2 and L3.1 there will be the week 10 folder. So far I have only shared the parts zip folder. That's the one that you will have to download, and I'm gonna store it somewhere in my hard drive. In this case I have a TA folder, so I'm storing it there. And then we can go to that location. Here it is. It's a zip folder. You can see the file extension by clicking in view and then checking file name extension. Or here in the type, you will see that the file has a type of WinRAR zip archive. In that one, I'm gonna press the right click in my mouse and then click in extract here. That's because I already have the software to unzip this kind of files. If you don't have one, I recommend you to use in Mac. You can use the Unarchiver, I guess is the name. You can find this one for free in the App Store, or you can find either of these two online. WinRAR is the one that I use in Windows, or you can use also 7-zip. There are many of these, and most of them are for free, so you can just go ahead and download them and install them. Since I already have WinRAR, I just right click here and then click it in extract here, and it created 2 different folders. One for Mac users, because I uploaded everything also for Mac users. And then for Windows, we have the bench vice assembly. In there, you will find all the different parts that we will be using today. All of these 10 different parts. Now, if you are, again, if you are unable to unzip the folder, you can see this tutorial on how to do these parts. Again, the purpose of this tutorial is not how to do this part, but how to put them together. So if you can avoid that, that's better, but it's up to you. Here are the blueprints if you need to model them by yourself. There is a total of 10 different parts that we will be using today. And this is the blueprint that I will be requesting from you in the final project. So for example, let's suppose that my group is only 2 members, and then we did these 10 parts. What I am expecting from you is to have a top view, a front view, and a right view. And these little balloons are called the balloon call list. They list all the different parts that are in this assembly, and then you will have to do a list like this, where you are having the number of the item, a name for each item or for each part, and then the quantity. How many times do I have to use any given item? Think about instructions like the ones you get when you buy something in IKEA, and then you have to assemble everything together. With this drawing, I already know what is the layout for each component in this assembly. It is clear, and I can see every part in the assembly, or at least I can differentiate which part is which kind of line in the drawing. So something like this is what I'm expecting from you in your final projects. With no more, the final project should, sorry, the final assembly in this case should look like something like this. And we can even render the whole assembly and show something really nice, really beautiful together. And I guess I will be doing that today as well. So I'm gonna open SolidWorks, and then I'm gonna create a new assembly. This time I will not go to the part module. Instead, I'm gonna go to the assembly module and then click OK. Now here in the assembly module, by default it is asking me to bring at least one part. So I'm here in the folder in which I have all the different parts for this assembly, and I'm gonna start with the body, with this one, the largest part in the assembly. I can place it anywhere, or I can just click OK. And then I'm gonna import a different component. In this case, I'm gonna import the jaw, which is this other component, and I'm gonna place it somewhere in the space. Now this jaw is supposed to slide on top of this body, so I can just move it around. I can also click in move component. I can also rotate this component, for example, like this. However, aligning this is a 3D manipulation in a 2D environment because I can only see each plane at a time when rotating this. So it is really difficult to orientate this by hand. I can try to move this and it will always be switched in one or the other dimension. So in order to avoid doing this by hand, what we can do is use the mate option, which is the second option that we have here. So far we already insert component. Uh, we we inserted these two components by using the insert component button right here. But then I'm gonna use the mate component or mate option to define relations between surfaces of different parts. So for example, I'm gonna select this. Actually, I'm gonna select the the hole that is going through that jaw, and this hole that is going through the body. And you will see that I have different options right here. So I can make them parallel, perpendicular, tangent, concentric. I can also lock a position, can make them parallel or define an angle between them. This will switch the direction. This will undo the action that I just did. And these same controls that I have here, I also have them here on the left. This is just a fast access to these controls. In this case, I want the concentric relation between those two. I'm gonna just click here in OK again. But you will see that this jaw can move anywhere in the axis of the center of this cylinder. They are aligned only in those two circles are aligned. So what I need now is to define that. Maybe I can say that um, this face here in the bottom of the jaw, and I'm gonna select it again, this one, is gonna be parallel to this one right here. I can make them coincident or I can define them to be parallel. Is the same. Well, it's not the same. With parallel, I can define a distance between them. Whereas coincident, it means that both surfaces are in contact all the time. In this case, I rather have them parallel. I can switch the direction, for example, and you will see that they are not touching. They will be only parallel. But in this case, we need them to be like this. So I can check this OK. And you will see that I can now slide this through that body. Okay. The other component that I'm gonna insert now is gonna be the jaw screw, this long component. And I'm gonna place it somewhere around here. And that looks okay. Again, I know that this one should go here, and that will this will be like a screw, and this will control the position of the jaw. So what I'm gonna do is I'm gonna add a mate relation between this cylinder and this other cylinder, and then they are concentric, and then I can click here in the check mark or here in this other check mark, and then I can move this cylinder inside and outside this hole. Now the problem is that even when this cylinder is moving, this jaw is steady. So I have to define a relation between the cylinder or the screw and the jaw. So to do so, what I'm gonna do is I'm gonna have a section view. I'm gonna select the front plane and then click here in section view so I can better see what is going inside. Now I know that this end of that cylinder is gonna be in contact with this wall all the time. So that's what I'm gonna do here. I'm gonna add that mate relation and this end. And then I'm gonna click OK. Now whenever I move this screw bar, it will move as well the jaw. However, as you can see here, there is a misalignment here between this hole, this vertical hole, and this revolution here. So this is what I was telling you, that I expect modifications on your parts. For example, let's assume that maybe I did a mistake when I was modeling this screw, but that's not a problem. I'm gonna save this assembly for the moment, and I'm gonna call this assembly tutorial. And if you see, the file extension now is different than with a part. In the part we had SLD as in SolidWorks, and then we had PRT as in part. In this case we have SLD SolidWorks ASM assembly. I'm just updating the version of this full assembly. I can click save. It updated everything. And then what I'm gonna do is I'm gonna open the jaw screw component, this part. I will open this part, and then in the revolution I have to do a quick modification here. So I'm gonna click in the sketch and then edit sketch, Control 8 in my keyboard, and then this dimension here is wrong. This should have been 9 millimeters, and then click OK. Now that it is 9 millimeters, I can exit this sketch now. This has been modified. I can just save this part, overriding the same component, and then I can open the assembly file, and it is asking me that it is telling me that there are some modification on some components, and if I want to rebuild the assembly now, I just click OK, and then we see that with that modification we did on this part, now the the two parts match together. So that's something cool about SolidWorks. You can modify files independently, and then everything will update it. Everything will update. Now I'm gonna deactivate this section view, and we see that it is taking shape. All right. Now what I'm gonna do is I'm gonna insert a new component. I have to click here in browse to find the other component that I'm gonna use. In this case I'm gonna use the screw bar. And this screw bar should be somewhere here. Then I'm gonna click again in mate. I'm gonna select this face of this bar and this hole here. Then OK. And it should go inside that, like that. OK. Now I'm gonna insert these bar globes. There are two of them, and I can either insert them twice, or a nice trick that you can do is you can press and hold the control key in your keyboard, and then select the ball and move it around, and that will be like copying that part. Look that if I do the same without pressing the control key in my keyboard, it will just only move that component around. So by holding control, it means that I'm copying the part. I'm gonna click here in mate. But first let me show you that this part is not completely the same in one side and in the other. So we have to consider, take into account that the first relation that I'm gonna do is the inside of the globe and the outside of this bar. They both are concentric. And then this flat surface that we have here is coincident to this surface here, but in the other direction, like that. And then I can click OK. Now look that if I try to move the, the globe alone, it will also move the bar, and the bar will move the screw, this long screw, and this long screw is gonna move as well the jaw. And that's because everything has a relation between all the different components. So I can do the same for this other globe at the other end. I'm gonna click a relation between this inner cylinder and this outer cylinder surfaces. Okay. And then look that in this face we have like two different faces, whereas in this one we have just a flat face. That's the one that I need to select. And then click OK. Okay. Look when I click in move component, I can uh, activate the collision detection and then stop every collision. It means that if I move this, it will detect that I have a collision somewhere. Okay. Um, the next that I'm gonna do is I'm gonna put some slide bars here. Well, first I'm gonna use the clamping plate. This one should go in these two holes. So the first thing is that this surface is actually in contact with this other surface here, but in the other direction, like that. Okay, I'm gonna drag this around. And then that this cylinder is aligned with this hole. And the same for this cylinder and this hole. They are aligned now. And if I move one, the other one should move. That's okay. Now I'm gonna insert as well these base plates. There are two of them, one at each side. So again, pressing Ctrl key and moving this around, I can have a copy of that one. I'm gonna do a relation between this surface and this surface, switching the direction, sorry, clicking here, flip mate alignment, and then OK. I'm gonna rotate this one. And then move it. So it's the other way around. This hole goes actually in this hole. I'm gonna mate this hole with this cylinder here. Okay, and then the other hole with the other cylinder in the front. Like that. And then, well, this is wrong. It should be the other way around. So I'm gonna close this and press Ctrl C in my keyboard to undo that one as well. Again, I'm gonna mate this cylinder, but this time instead of selecting this, I'm gonna select the one in the front. And the same for this other two. Okay. And now we see that the body is completely aligned with the body. For this one, I'm gonna select the bottom surface and this bottom surface. Switch. Okay. And then this face with this one. Okay, and this face with this one. And they both are disaligned, so again I will have to cancel this one. I will show you as well how can I delete a relation. So I can click here in mates, and the last one that I selected, as you see, if I have all the list of relations that I have created so far. This concentric relation between the screw and the inner cylinder of the body. We have a lot of relations there. Now the last one was these two cylinders. I can just right click on that and delete. And then in this confirm delete, I will click yes. So I can move this one around freely again. The thing is, I had to select this cylinder and this other cylinder. And we see that everything is nice and aligned. Okay, now I'm gonna import the screws. These two set of screws. And as you see, both of them are different. So if we check on the assembly, we see that the ones that goes in the plates in the bottom are the part number 9, which are the set screw number 1, and then the two screws that goes in the clamping plate are the number 10, which is the set screw number 2, which are the longer ones. That means that I need 2 of these and 4 of these. So pressing Ctrl key in my keyboard, I can do the copies that I need. There they are. And then I can just define the relations. I'm gonna start with the second set of screws, the long ones, that goes inside here, like that. And then this surface is in contact with this other surface here, and that's okay. And the same for this one here. This one goes here, this one here, this one goes here, and this one goes here. We have all of those screws in there. And finally, we need one last one. This oval Fillister that goes inside here. So I can define this face with this face, and then this bottom face with this upper face here. And to check that, again, I'm gonna use the front plane section view, and we will see that that Fillister is matching the hole inside the screw bar. So if I move the screw bar like this, we will see that it slides in that Fillister. Control 7. And that's our assembly right there. Now I could just define the colors for each part and do a sketch. So for example, let's suppose that I have some sort of glass here for this component. I know it's not a good idea to have glass there, it's just for the purpose of having a material that let me see through like that. So the correct way to do that is actually I select the part, right click, and then here in edit appearance, I select this. In your case, it should be white, but this sphere here, and then I look for the material that I want. In this case, I selected appearances, glass, thick gloss, and then green thick gloss. Sorry, green thick glass, and then okay. Now I want maybe this whole thing to be, I don't know, maybe gold or something like that. Gold, something fancy. And then these two screws here, maybe I want them to be made out of rock. So we're looking for rocks, maybe stone here. Yeah, bricks. I like that. Why not? And then maybe I'm not gonna use gold for this. Maybe I'm gonna use something that also allows me to see through. Maybe some sort of, what do we have in miscellaneous? No. Okay, not in miscellaneous. Maybe a plastic. Yeah, why not? An acrylic. No, acrylic, no. What do we have in lights? Organic sky. We can have a material made out of air. This one, I like this one. Or this one. Amber beer. White wine. More oil. Water wine is fine. Okay. I just want to see the parts inside. Appearances. I'm gonna change this one for something more wood. Let's use wood. No, I'm gonna use wood for this one. There it goes. And now gold for the globes. And then for these ones, rubber. Like tires. That one is nice. And then for these screws, another metal maybe. Silver. Polish silver. Bronze. Grass. Okay. Control 7. And then here in photo view, in SolidWorks adds in photo view 360. It is activating the package. Now save this, save all. And then here in render tools, integrated preview, We continue with the camera perspective. Will be something like that. Maybe just final render. Abort. Yes. Final render. Of this size. I'm gonna save this render. And there we have the final render. We have wood, gold, bronze, rubber in the bottom. Well, guys, I think that's all for today's lesson. We learned how to do this assembly. Remember that for this week, all you have to do is submit the third part of your final project, and that next week you will be doing the homework number 8. Telling from today it's gonna be also an assembly, but for a different components, and you will have the fourth part. There is no quiz or exam next week, so you will have all the time to do that assembly. Take the time to practice this one. I think it's very clear. And if you have any questions, just send me an email, and you can also find me in GroupMe. Thank you very much, and have a nice day.